Hello, everybody. I thought I would do a kind of a, relatively quick knowledge share and or high-level overview on what I've been kind of fishing, if you will. Fishing is a term I like to use to explore something that I'm not all that familiar with, just to see what it's about. I don't claim to be an expert at any of this sort of stuff. Just learning it, just like others out there are learning it. But I thought I would share it. Machine learning is one of those things that I've been kind of intrigued about. I've been continuously putting it off to check into other things or spend my time in other things. To be honest with you, I've taken a course on some of the machine learning algorithms like k-means, with nearest neighbor, things of that nature, learning about regression as well as classification and building models and things of that nature. And again, I'm in no way, shape, or form any kind of an expert, and I consider myself pretty much at the beginner level, although I feel I can catch on relatively quickly. I'm not, totally comfortable with a lot of the mathematics stuff, although from what I'm hearing from some of the other developers and such, usually a data scientist would take care of building the models and training it, and then as a developer, you you would basically take the models and such that they have built and trained, and then you would write code around it to either spin up the services and or write the front ends, which allow people to invoke, and run the predictions as well as to display the results. So my understanding is that's typically the way things go, but that's not to say you may not have a developer who's also got the role of a data scientist on top of that. As far as programming languages are concerned, Python seems to be the leader in the industry, and I know JavaScript is getting more and more popular with the JavaScript version of TensorFlow, which is a high-powered library which allows you to create, build, and train your models and such. So being that I'm familiar with AWS and a lot of aspects of some of their services and such, I thought I would kind of dive into the machine learning aspect and see what AWS has to do, it has to offer in that area. I know that Google Cloud has a really sophisticated machine learning service. I know Azure has one, and I try not to be married to a certain vendor. I kind of, go into each one with an open mind. So for this thing, I'm just kind of exploring Amazon. So there is a service in Amazon called the Machine Learning Service, and I'm going to actually pull a twist here. Even though I'm on this page, basically I'm not going to actually show anything on this page because, to be honest, I've been redirected to another service from Amazon. If you look to the top here, the Amazon ML is no longer available to new customers, and they're basically saying use Amazon SageMaker. So my gut feeling, my understanding is this supports only like a subset of algorithms and things of that nature, and Amazon is actually wanting people to move away from this particular service and to go into SageMaker. So I'm kind of pulling a twist on you there. So what you want to do actually is take a look at SageMaker. And in a nutshell, SageMaker allows you, with the help of something called Jupyter Notebooks, which is an open source project, Jupyter is, so it's not specific to Amazon. Think of Jupyter's kind of like what Kibana is to Elasticsearch. It's an open source, shall we say, interface, which allows you to create and query your data. Like that's what Kibana is for Elasticsearch. So I kind of see Jupyter as the same thing for SageMaker, and SageMaker is a service that allows you to create Jupyter notebooks and stuff, where you can run Python commands, and not just Python, but other types of languages, and I'll show you that in a little bit too. But the idea, though, is SageMaker makes it much, much simpler than the Amazon ML to build, train, and deploy your models at scale. And then you can actually create endpoints after you've built and trained your model with training data. You can actually deploy endpoints, and these endpoints are basically backed by high-powered EC2 instances. And we're talking, you know, the ML, CFAR large, those kinds of things, where you're going to pay a little bit more for those, but they're going to crank and churn and allow you to predict and see the projections and things of that nature for the problem at hand. So one of the things I'm just going to demo is just how to create a Jupyter notebook and how to build and train and deploy a model. But I will say one thing. I am not going to take credit for what I'm about to show you, because it's only fair to give credit where credit's due. I have a Pluralsight subscription, and I took this particular course right here, which is deep learning using TensorFlow and Apache MX on AWS SageMaker. And I've been kind of toying around with the algorithms and things of that nature. So this gal right here has put together a really enjoyable course. And even if you don't have a lot of the detailed knowledge of the mathematical algorithms and models, that's okay, because she walks you through a lot of steps just to get, you know, she walks you through what's involved with getting things started and getting your Jupyter notebook instances created and pumping in commands. So I'm going to kind of just show that based on what I've been taking in this course, so you have an idea. And I will not take credit for the Python commands and such, because it's coming, a lot of it's coming from this course. But I highly recommend, if you're really interested, to take this course on Pluralsight. And without further ado, you know, I'm going to also show you some slides and things of that nature. But the machine learning workflow, you know, basically it's just you're collecting data, you're training your business model, and when you collect data, you're actually collecting and formatting the data to the algorithm you wish to use. Now, there's many different types of algorithms, and I'm not even going to go into them, but some of them are linear-based, classification, regression-based, k-means. There's other ones. There's all kinds of topics, and a lot of the data scientists out there will actually use certain types of algorithms to solve certain types of problems. So that's kind of outside the scope of this particular demo that I'm going to show you. But the idea is you can use this flow for any of those built-in algorithms, which will solve any type of problem you're looking for, whether it's speech-to-text recognition or just predicting upon a, shall we say, like a linear flow, or a classification where you're basically going to kind of get a binary result. You know, is this a digit or is this a letter? Those kinds of things. So you would collect the data and you would prepare the data into a format that the algorithm expects. And you're collecting a whole ton of data. And why are you doing that? Because you're actually training your model with all of that data. The more data, the better, and the more accurate that your model can be. And you go through kind of like an iterative cycle there. And then when you're relatively satisfied with that, you can deploy and host your model. Now with SageMaker, you can deploy it and host it. And basically you will get an endpoint. Think of it kind of like as API gateway. It's kind of like a RESTful endpoint, and you're passing parameters in and you get a result back. And the result is the probability of this or the probability of that based on the parameters that you've passed into the model that you've already trained. So having said that, I'm going to kind of go through some of the steps of creating, you know, a notebook instance and actually deploying. So A notebook instance, so what you have right on this Amazon SageMaker is you've got concepts of training jobs, you've got concepts of algorithms that you can use, or you can create your own algorithm, to be honest. So you can go to the marketplace and you can get other types of algorithms. Again, this is not a course, or this is not an overview on the algorithms per se. You know, like myself, I'm assuming that, you know, you can take some other courses out there to learn more about, you know, data science per se, which gets into the different types of algorithms and scenarios. So Pluralsight and Udemy and other online Coursera, they have some really good courses on machine learning from a mathematical algorithmic standpoint. So the next question you may be asking yourself is, what is a notebook and what is a notebook instance? So basically, I like to think of a notebook like, here we go. Amazon SageMaker provides pre-built functionality, fully managed notebook instances that run Jupyter notebooks. And these notebook instances include example code for model training and hosting exercises. In a high level, shall we say, concept about what a Jupyter notebook is, for anyone out there that, you know, writes JavaScript code and all that, you're probably familiar with things, you know, utilities and tools like CodePen, where you can actually do scratch pads of JavaScript examples, HTML, and then you can save it, and then you can actually share code snippets and things of that nature. I kind of like to think of Jupyter notebooks as something similar to that with respect to creating, training, and deploying your models. So let me try to find something here for a second. So Jupyter is an open source project, and again, I don't claim to be an expert at this because I'm still learning and I'm just getting into it. But basically, I like to think of it as a code pen, but it allows you to kind of create scratch pads of test code or actual running code using a myriad of programming languages, and one such programming language is Python. And the key point right here is it's an open source project, so you can download it and install it on your standalone box or a Linux instance. It doesn't require AWS, so that's a key point. Just like Elasticsearch and Kibana, it doesn't require AWS. But AWS, Amazon SageMaker, just conveniently allows you to create notebook instances that'll actually integrate with the SageMaker, shall we say, service. So I'm going to go ahead through the actual course itself and just kind of walk through some of the steps here from the course. So we will create notebook instance called Looney Instance 1. And this is actually going to be an EC2 instance. An M2 Medium is basically the lowest end model that you can use in this case. And by the way, this is not free. It's not a part of the free tier. So if you do kind of, as you're exploring SageMaker and things like that, if you don't have a free tier account, which I don't because I've had my account for well over a year, probably 2 years, you know, trying out various things, you will pay some money for this. Not going to be a lot as long as you tear down your instances and such and don't leave them running. So that's very, very important that you tear these down. Anyways, having said that, I'm going to go ahead and create a notebook instance. I've created a few of these, and so I'm going to use an existing role that I have right here. Don't really care about Git repositories, or I don't really care to put this into a VPC where others could use it or anything of that nature, and I don't really care to, yeah, I might as well tag it. It doesn't hurt. So we'll just say AWSML. And I'm going to go off and create this notebook instance. This will take a bit of time, so it's in the pending state. So I am going to stop and pause and then resume this when that's finished. Okay, so that finished. As you can see, my notebook instance, ML-T2 Medium, has a status of in service, and you can see right here it allows you to open Jupyter. I did want to quickly touch up on these built-in algorithms. So SageMaker, what's really kind of cool, for someone like myself who is not an expert at a lot of the internals of machine learning in general, and I would imagine, there are others out there who may be, like myself, who may have kind of been a hesitant to try out machine learning simply because I haven't had much time to really dive deep into some of these algorithms. Amazon has actually taken that, shall we say, anxiety and or burden's not the right term, but that task away from a lot of developers who fall into the same situation as I do, where they already provide you a lot of pre-cooked, pre-baked, commonly known algorithms out there in the marketplace, in the industry. And here's some of the built-in algorithms that SageMaker supports out of the box that you can just go ahead and use. And all you really got to do is feed a whole bunch of data into your model that's using these algorithms. And I'm not going to go into any details or actually even click on these, but if a data scientist who is a guru and all that in mathematics and predictions and stuff like that, and maybe not necessarily in programming, but those data scientists are going to know a lot of these algorithms basically, and what they do and which, how we want to say, situations that they apply and are best suited for based on your business problems. So SageMaker allows us. I know that the k-means and the k-nearest neighbor are pretty popular ones. So, I took a Stephen Greider machine learning JavaScript course, and he went pretty deep into the k-nearest neighbor algorithm and situations on when you would want to use that. But I just kind of wanted to plant the seed in your brain that a lot of these are very commonly known algorithms for machine learning that data scientists use in production today. And so Amazon has a whole bunch of them covered, which is really good. So now that this notebook instance is up and running, I'm going to open up Jupyter. So I click on that, and you can see we are getting redirected, and you get this particular page right here, which gives you all these given examples. Think of these kind of as like, I almost want to say like CodePen templates and or projects out there. But if you look here at these sample SageMaker examples, I mean, you can just spend a whole ton of time just checking a lot of these examples. So you can actually click use and preview for the most part, and you can find out, what those algorithms like the XGBoost algorithm, you can go through some tutorials in here. So this is really, really good. And, even if, like myself, if you're not an expert or you're still beginning through this, you can kind of, quote unquote, bluff your way through at least the algorithm part and just kind of get a feel for how this works. Again, these examples are in Python, so you should have some familiarity with Python. If you don't, Python is almost pretty much self-explanatory, or you can at least look at the code and pretty much know what it's doing. So I am going to, now that I've actually got this running, this Jupyter notebook thing running, I'm going to go ahead and do this Pluralsight example. So we can create kind of like a new scratch pad. And so these are, you can use the R programming language for machine learning. You can use TensorFlow. We're going to use Conda Python 3. So when we use Conda Python 3, what you get is this. And by the way, you can save. You can save your scratch pads and things like that. So right now this is unsaved, but kind of like with CodePen or whatever, you can save all of these snippets and retrieve, go back to them. So this is kind of like an interactive shell. And if you take that particular course, just for the this one example, which is, the linear example, she walks you through a whole bunch of commands that allow you to basically train your model and then deploy it. And then you can actually run examples off of it. So what would you do inside of here? Well, basically, you can just start coding Python. So as you can see, I'm pasting a bunch of code in here. You can code a whole block here or just parts of it. And then you would hit Shift Return, and you can see that that's been complete. Now we're going through. So what I'm actually doing right here is I'm actually going to be training this model. And so these are prepackaged zip files basically for MNIST. This is going to be like an image recognition example where you're going to create an array of all kinds of images, and then it's going to attempt to return whether or not a particular image denotes the number 3, just for this example. So it may or may not be useful, but it's showing kind of like how this runs. So this second part here is actually a continuation of the first part. So think of it as you're partially building a Python set of commands as you go along. So I'm going to do a couple more here. And again, that Pluralsight course will actually walk you through it. So, it'll actually walk you through a lot of these right here. So, I'm not going to go into great detail here. But what we are doing is we're downloading data sets, and we're opening and loading our data set, and we're going to use, the algorithm at hand, training our model, for example. So now that we've got that loaded, we can go ahead and do a print here. We can print out the shape. So we actually are, we have 10,000 images of 784 pixels in our validation set, our test set, and then our training set, which we're actually loading a lot more data. So the training is actually where you want to give more data to your model so that it can produce more accurate results. So as you go along the way. So the next set of commands is just basically a little bit of debugging, converting some of your Python objects, vectors, creating labels, and you'll see where this is coming from, or where this is leading to. But as you can see, when you do something like this, it's just basically dumping out the contents of that. So the next step is we're actually going to be training our model right here. So I'll paste that in. And as you can see, what we've got here is this, like, again, if you walk through the course itself, I've actually created a S3 bucket as well, because SageMaker is going to create, put all of the artifacts for the model that it's created, and it's going to put it to a bucket, for later use when you actually create an endpoint. And the endpoint is actually going to refer to the model, so it's going to pull the artifacts out of your bucket. So let's go ahead and do that. So what we're really doing is we're just creating our training process right here. So this takes a little bit of time. As you can see, there we go. It just came back. So we're training our model, and then we're uploading all of our artifacts to an S3 bucket. And this also is really kind of interesting. Now we're actually specifying built-in algorithms for our training data. And that's the other thing. These built-in algorithms are actually stored in containers that are running like in ECR. They're from the Amazon Container Registry. So it's actually going to go ahead and invoke these within ECS behind the scenes. So we're setting up the different containers that know about the linear learner algorithm. And you can have different versions. So these are, containers stored in Amazon that they've actually created for this particular algorithm. So now what we actually want to do based on that we're just going to grab the one that's closest to our own region, and we're going to create a SageMaker session. So again, you know, the SageMaker, it's just, you know, going up and down the line right here. You can see it's from this import. We're actually creating a session. This is Python code. We're getting our execution role, and this right here is just dumping out the ARN for that role. And then what we're actually going to do is create the estimator. So the estimator is a high-level API, and the concept behind the estimator is it's going to abstract away the entire training and prediction process that runs behind the scenes. So it's something that SageMaker uses. So I almost like to think of it, although it may not be the right type of verbiage, I like to think of this as kind of like a facade or a gateway, this object right here. And behind the scenes, you know, especially API gateway where the back end, maybe a Lambda or whatever, you know, I kind of like to think of this as this is your API gateway, and it's going through your different steps in the gateway, and the very back end as it goes through different steps. Instead of calling the Lambda like your API gateway would or an HTTP endpoint, we've got this estimator, which basically behind the scenes is going to kick off this given model, and it's going to create the training on this C4 large instance. So let's also go ahead and do some hyperparameters. And hyperparameters allows you to specify more parameters to your linear process, if you will, in your estimator, if you will. And so we're just basically saying, hey, you know, we're creating this estimator, and now we're just saying, you know, when we run this job, because we're going to actually run a job that's going to actually go ahead and create all of the artifacts and kind of like compile our model so that we can deploy it to an endpoint. But, you know, there's regression type predictions where regressions are kind of like values that are derived over time as values are learning. They're dynamic. The model, as the model learns and goes along, it starts predicting and creating more probabilities as you go along. Whereas with a classifier, it's kind of like a binary. It is this or it is not that. So in this case, in this example, we have a whole bunch of images that we're pumping into our model, and we want to basically say, is this, you know, here's an image. What is the likelihood that this image represents the number 3? I know it's a real simple example, but it's going through these processes. So we've set up our hyperparameters. Now our next process right here is going to take some time. This is where we're actually going to start the job. So we've created the estimator and told it, hey, when you start the job, create it and compile on this large instance because it's going to take some time to actually run the job. And oh, by the way, you know, each of your, you know, these are dimensions for the images. You know, these are 28 by 28 images. So this is our predictor type. How do we want to use it? And then we have a batch size. So let's go ahead and start the job. So as you can see right here, this will actually take some time. And if we did everything correct, you're going to see a whole bunch of output scroll. So behind the scenes, it's actually it's spinning up this C4 large instance, and it's actually going to go ahead and, you know, run these commands. So if you go back to the SageMaker console, you can see right here, you know, we've got algorithms, we have training jobs, and if you look here, you can see some of the basically jobs that we've run, things of that nature. You can see this particular job right here. This was done earlier, you know, when I was kind of experimenting around. You could see this ran 5 minutes. Here's a job that we're running right now. So it's actually in progress. So you can just kind of take a look. Think of it as kind of like CloudFormation when you're spinning up a stack and all that. You can look at the different metrics, the phases that it's going through. And before I keep rambling on, I'm just going to pause this and let this thing finish. And I will resume when this particular job is done running so that you can see what goes on here. So right now you can see it's launching the requested machine learning instance, which is this. So I will pause it and then come back when it's finished. Actually, I kind of lied a little bit. So I told you I would pause it and then come back when this is finished. But another key point I wanted to make is while the job is running right now, it's still not finished. So it's actually, you can see it's going from step to step, and it does take a little time. But as you can see, it's actually creating and launching these instances right here. One of the key things to mention is if you go back to your EC2 console, you're not going to see, if you click on your running instances, you're actually not going to see any running instances. It's not going to show up here, but behind the scenes, be aware that it's actually running and using instances. So I guess, and I've seen kind of the same thing happen when you deployed your endpoint. Pretty much like Elasticsearch, it's the same thing with the cluster there. So you want to pay attention, and when you're done, if you're just playing around with this and not using it in a production environment, you really want to pay attention and make sure that you delete your notebook instance, because I actually have two instances running right now. I've got my notebook instance and I've got this job running on this instance. Now actually when the job is finished, it's gonna bring the instance down, the training job instance one. But when you do your endpoint, it's gonna leave the instance up. And again, you're gonna wanna make sure that you tear down your notebook instance as well, because you will be billed for that if you leave that running. So here we go. So we're actually, I think we've actually finished. That's a good sign right there. So what have we got going on here? So as you can see, we've started the job, we've launched the instance, we've downloaded our input data, and we've downloaded our training images. And as you can see right here, this is where your algorithms are. They're actually built-in algorithms are actually running inside of your containers. So in no way, shape, or form am I even going to try to explain what's going on here, because I really don't have a lot of detailed knowledge about these algorithms myself. I am not a data scientist, although that would be something that would be really nice to be, and I wouldn't mind getting more and more knowledgeable in it, but I'm just kind of scrolling down here. So it looks like you've got different steps. It's just your basic output that's going on as it's churning and training your models. So we'll scroll all the way to the end. So we've actually trained our model here, and it's complete. So if we take a look at go back to SageMaker, go back to your training jobs, and here's the one that we just kicked off. So it went from pending to completed. We click on that. You can see, you got your different types of metrics, not really much going on here. You have your output artifacts, and that's one of the things I wanted to mention, is it will dump this to an S3 bucket, and here's your model right here. And if I take a look at it, it's, here's our model right here. So here's the size. And what happens is once we create and deploy the endpoint, it's going to use this model that we've created. So the idea is you can go ahead and continually train your models and create new endpoints based on those models. So it's an iterative process, or you can make updates to existing models. So that's the power and the beauty of these Jupyter instances. So I'm not quite done yet. So what we've got going on right here is, yes, we have a model trained and we've got the artifacts. Now we want to make it available to consumers, which could be maybe one of our own back-end APIs or what have you, a way for us to call it such that we can pass in the parameters. So that involves deploying our model. So that'll be our next step. So getting back to this particular chart, so what we've done up until now is we've collected the data, we've trained our model, and now we're ready to actually deploy and host the model. And once again, SageMaker seems to really do an excellent job at that. And as you continue on with that particular course, she walks you through the steps needed to deploy the model. So let's continue on. So we're pretty much almost done. So the next set of steps right now is we're going to basically paste in more commands, and she goes over a lot of what's going on here with these commands. We're going to actually deploy our model now. So as you can see, we're still acting on this linear object that we created above right here. And that's the SageMaker estimator. So we've created that model. Now what we really want to do is we want to deploy it. You can specify multiple instances. Here's where you can actually deploy it, specify your instance type. And, you can specify when you return or you save or export. You can specify the format of your content. So we want to get our data back, through JSON. And let's just go ahead and deploy our model. So I'm going to actually get rid of this because that'll be the prediction step. So this is where it's actually going to deploy. So let's actually, I'm going to do this too. So if I just hit return, this is going to take a little bit of time too right now. So what it's actually doing is it's actually going to create one of these instances, and this will kind of scroll as it's going on, and it's going to create an endpoint for the most part. So let me take a look at right here. So we haven't really seen our endpoint configurations yet. You've also got, things like models and packages that you can specify, and then it tells you the models itself that it's using. And then your endpoints. So as you can see right here, just by running this one command here, this linear deploy, and like I said, it takes time because it's actually working. These dashes keep going across. It's in the process right now of creating an endpoint, which is kind of like if you've worked with Elasticsearch or whatever, it's kind of like when you create a cluster, it's creating an endpoint for that cluster. So I will stop this and wait for that endpoint to finish. Okay, as you can see, it took a while, but it looks like our endpoint is done. And basically, here's our ARN for the endpoint. So here's the way that you can actually access your endpoint through the API and things of that nature. But let's go through and just kind of, on that endpoint itself, let's just go ahead and run some quote unquote predictions and all that kind of stuff. So let's set up, we're going to switch to the SageMaker console. And it'll create like an endpoint configuration. So let's go ahead and run these commands right here. So we're prepping the output. And we are going to give it, we've got going right here. We're going to say, okay, let's predict this based on an image. So here's our training set. So I could tell you based on the training set itself that we created earlier on, in this particular first array here, we have multiple arrays of arrays in here, but the first array and the 30th element, it's a two-dimensional. That actually is an image, and that is an image that denotes 3. So this predictor that we've actually trained our model with all the different images is going to come back and say, what is the likelihood that that value or that image that we passed in denotes 3 through image recognition, all that kind of stuff. And it's going to say, well, It's 1.0, so it's 100% on our label right there. And so there's our score and the probability. So that's actually pretty good. So I mean, here you can see if I pass a 1, you can see that that is not actually a 3 in that case, so we get a 0, you know, based on our model. So, you know, we've got basically, let's see here, if you pass 29, you know, these are all not 3s, but I can assure you the 30th element is a 3, and it comes back with a 1. So we can actually run multiple sets here. So we can run a large set against that model. And we'll actually use the NumPy thing right here. So we've got our batch test set. So we're splitting this array into here. And then we're going to actually, this is kind of interesting. Based on that array that we created, this batched test set array right here, we're going to loop through each of those elements inside of there, and we're going to predict on each one of those. So let's do that. So it's going to, you know, call predict for every batch of 100 images, and then it's going to append the prediction label to each iteration of the array. So this is going to take a little bit of time. Okay, so here's my list. So we can actually print out the results. So as you can see, that's the result array. That's what we're passing into each of these predictions right here. So as you can see, these are all the different images and the score on those. And it's just basically coming back with the actual predictions. As you can see, we've got some of the number 3s in the images right here because it's coming back and denoting that based on the training model that we've created. And here we can just print out, you know, certain subscripts in more detail. We can print out the last column right here, which is the value of the predicted label, which is what we've got going on here. Now we'll do a few more things. Just to show you some of the things that you can do, we're creating an array using NumPy based on those predictions, and we're dumping that to the output. Okay, now I'll show you something else that I thought was kind of cool. And again, you know, I don't claim to be an expert at this because I'm still learning. Just print out the actual. Okay. We could do something like a crosstab, which is really kind of cool. So I'm going to paste this in, and we'll just take a look at it real quick. And a crosstab, it's going to use the Panda library. It's just basically saying, based on the data that you have in your model and the number of times that you ran data against that model, how accurate was it? So, and what we've got going on here is this is pretty accurate. This basically, let me just paste this in. These were like some of the notes. So it's just basically, I mean, she calls this a confusion matrix, but if you kind of go on the diagonal, so here's the actual, we got 0 or 1. So what is the probability that the image you pass in is not a 3 as opposed to what was a 3? So if you kind of take a look at it, the 0 is it wasn't, and the 1 was it was. So what you're looking at here is from the real data. You know, we had you know, these reports of 8906 where it wasn't, and then we had reports of like 870 where it was. So what this basically is saying that, you know, we really did have, you know, an accuracy of 97%. So out of the 10,000, you know, labels that we passed in, images and things that we were comparing and all that, with the data going against, 9,700 of them were accurate based on the model. So that's pretty darn good. So I probably didn't say that too clear, but this is a good measurement of accuracy. And so you can use the Crosstab in the Panda library for Python to do just that. And so here's your predictions, and you know, so you got your actuals and your predictions going on right there. So kind of clearing that up a little bit. So predictions was the array that we created, the batch array right up here, based on all of this. So we actually had a total of 10,000. So if you were to say like len of predictions, you can see that we had 10,000. So we just ran like 10,000 against our model. And what this basically saying is, you know, 8,906 were entirely correct, where it wasn't a 3. And then, you know, basically we had 870 were entirely correct where it was a 3, and 140 were incorrect. And then where we were passing in images that weren't a 3, 84 times it identified it as a 3, which, you know, so these models aren't really going to always be 100% accurate. That's just the nature of machine learning. You want to keep refining it. But a 97% accuracy rate is pretty darn good. So having said this, let me just go back to some of the few more here. So here's our endpoint. As you can see, the metrics get updated right here, so you can kind of take a look at, you know, some of the various things, your runs, your utilizations on memory. Is there anything else I want to mention in here? I guess there was one more thing. So based on our endpoint, which you're looking at right here, here's another site here, or another page that shows you different ways that you can invoke, you know, you can invoke your endpoints. So again, you can do it as an HTTP post request where you pass in the body, you know, so it gives you examples of some of your common data formats on which you would like your body to look like. It gives you, you know, examples in your Python code and JavaScript code. So let's just go back here. Here's an example request right here. So here's your endpoint name, which would be your ARN. And here's like another way to call it with your payload. And then you can get your response. There's all kinds of different examples in various programming languages on how to invoke this endpoint. So I know I probably rambled on a little bit here, but I didn't claim for this to be any kind of a tutorial. I just kind of hope that anybody who watched this, who didn't know anything about machine learning on Amazon or SageMaker, I'm just hoping that, you know, this gave you a high-level overview on what's involved and what you would need to know in order to do further deep dives onto the subject. And I plan to continue to do deeper dives, and through the Pluralsight course, there's other algorithms that they talk about and other examples. So I hope this helps. Thanks for watching, and sorry again if I rambled on. Hope I was able to help somebody out there. So we will talk to you soon, and have a great one. Thanks again. Bye.